Hello and welcome back to Mr. Powers Teaches Algebra 2. We're doing algebra. And we are still messing around with finding zeros and roots of polynomials. But, you know, it's more now. We're getting more than just quadratics. We can do cubics, we can do quartics, we can do anything, kind of. We're getting there. So, today I want to talk about, officially, the multiplicity of roots. All right, and I want to focus on a few examples. So again, we'll start off this section by defining what a root or zero of a polynomial is. And I am using Paul's math notes. We say that x equals r is a root or zero of a polynomial, p of x, if p of r equals 0. In other words, x equals r is a root of a zero, a root or zero of a polynomial if it is a solution of the equation p of x equals 0. Well, we're going to do a couple of these, so don't worry about this. The next thing, too, we can have roots that come up more than once. And if it comes up more than once, we say it has a multiplicity of, let's say, 2. If it came up twice. If it came up 3 times, multiplicity of 3, and so on. That's what we're saying in the next paragraph here. Right here it says, now, we've got some terminology to get out of the way. If r is a zero of a polynomial, and the exponent on the term that produced the root is k, then we say r has a multiplicity of k. Zeros with a multiplicity of 1 are often called simple zeros. Okay, so let's go ahead and do some examples of these and it will become clear. All right, so let's take a look at x squared plus 2x minus 15. If we were to factor that, we would get x plus 5 times x minus 3 equals 0. And which we did in the last video, quickly. And what that does is this gives us 2 zeros or 2 roots. One at, for this one here, x equals negative 5, and for the minus 3, we get x equals 3. There's our 2 zeros. So you'll notice here, for a polynomial of degree 2, like a quadratic, we get 2 roots. Okay, that's something we've done a lot of quadratics and we always get 2 roots, except maybe in this case, right? Down here we have x squared minus 14x plus 49, and if we set that equal to 0 and solve in order to find a 0 or root, we get that actually it's the same as x minus 7 times x minus 7. So we can factor it into 2 linear factors, but they're the same linear factor. And so we get x equals 7, but it comes up twice. So we'd say x equals 7 is a root of multiplicity 2. Of multiplicity 2. Now, so with this kind of terminology and thinking, we would say again, a quadratic or a polynomial of degree 2 had 2 roots. All right, it's very interesting. Let's do another example. 5x to the 5th. This is a polynomial of degree 5. Minus 20x to the 4th plus 5x cubed plus 50x squared minus 20x minus 40. If we set that equal to 0 and factor it right here, what would be our roots? Well, here we get a root of x equals negative 1 with multiplicity. Let's do it like this. With multiplicity 2. It happened twice. And right here, we get another factor cubed. So we get x equals 2 would cause that to be 0, but it came up 3 times. So we say x equals 2 is a root or a 0 with multiplicity 3. And so negative 1's a root twice. Negative 2 or 2 is a root, 3 times. How many roots were there? There were 5 roots for a polynomial of degree 5. Okay, we're starting to see a pattern. Now if we do a polynomial of degree 8, how many roots do you think there are? That's right. There should be 8 roots. It's kind of a neat little thing. Let's see if it happens. Here we have just x. Just x is the same as x minus 0 for anyone who maybe that causes some issues just seeing x by itself. What's the solution? It's 0. Plug in 0 and it makes it 0, right? So we could rewrite it like that if we really wanted to, but this x to the fourth gives us that x equals 0 is a 0 or a root with multiplicity 4. So it's a root 4 times. Here, x minus 3 cubed, so that gives us x equals 3 is a root, because 3 minus 3 is 0, with multiplicity 3. And then, last but not least, we have this x plus 5 factor raised to the 1, right? There's only one of those. So it's a simple root. X equals negative 5 is a root with multiplicity 1. We say it's a single root. I guess we might say 3 is a triple root. Probably could say that as well. Okay, so what's the whole point of this, right? Oh, and we got one more. Okay, so we have sorry, I forgot how many of these I put in here. We have another polynomial of degree 7. How many roots are we going to get? 7 of them, right? Here we had 8. 4 plus 3 plus 1 is 8. So we did have 8 roots again. Here we're going to have 7, right? We have negative 1 is a root 3 times. We have here x equals 1 is a root 2 times. And then here we have x is negative 5 gives us a root. And x equals negative 4 is a root. So that's 1, 2, 3, 4, 5, 6, 7. 7 roots. So that degree, the degree of the polynomial will tell us how many roots there are. That is what we're getting to. All right? And so, without further ado, the fundamental theorem of algebra. If p of x is a polynomial of degree n, then p of x will have exactly n zeros, some of which may repeat, but it'll have exactly that many zeros. Some will repeat. So we've seen that. Now there's one thing, though, we have to consider. Are they all real roots? Of course not. We've seen plenty of times equations that have 2 roots that are not real. Let's say x squared plus 4 equals 0. That is a quadratic or a polynomial of degree 2. It does have 2 roots. We've seen that before. We've done that. But both roots are complex numbers instead of real. So this does include those. So the n zeros, of a polynomial of degree n will have n zeros. But some of those zeros could be complex numbers. So don't assume they're always going to be real. Just the examples we did were real. All right? And that will do it for this video. So, until next time, enjoy doing math.